Okay, this is going to be helpful for you to do the following worksheet. I'm going to do an example of each type of problem. So number one says Sarah has 19 coins in her purse made up of quarters and dimes. The total amount the coins are worth is $3.10. Write a system of equations that could be used to determine the number of quarters, x, and dimes, y that Sarah has, then find the number of quarters and dimes. So again, we got 19 coins and it's worth $3.10. So my two equations, x is the number of quarters, so I'm going to have x plus y is the number of dimes equals 19. Now, the $3.10 comes from the total they're worth, so I look at it, and a quarter is worth 0.25, so I got 0.25x plus a dime's worth 10 cents or 0.1. If you want to put 0.10, you can. Equals $3.10, and again, if you want to put the 0.10, you can. So now I got a system of equations. X plus y equals 19. 0.25x plus 0.1y equals 3.1. Now I need to add two equations to use elimination, but again, we're at that point where if I add here, nothing cancels. So we can multiply both equations. There's an imaginary 1 in front of this x, so I can put it on bottom. I can put the 0.25 on the top equation. And again, I like to make the number that's not 1 negative, so 0.25, negative 0.25. So now if I multiply the top by negative 0.25, I get negative 0.25x minus 0.25y equals negative 4.75. And on the bottom, everything times 1 isn't going to change it, so it's just 0.25x plus 0.1y equals 3.1. Now if I add these two together, the x's are going to cancel. Negative 0.25 and 0.1 is negative 0.15y equals negative 4.75 and 3.1 gives me negative 1.65. And if I divide both sides by negative 0.15, I get y equals 11. Now, so that's the number of dimes. Now it also says find the number of quarters, so I can go back and pick either one of these equations. X plus y equals 19 is probably the easier of the equation. This part you may be able to do in your head, and that's fine. So I got x plus y equals 11 equals 19. So subtract 11 and get x equals 8. So that means there was 8 quarters. Now on problems 5 through 8, there's actually a small typo. Says made up of quarters and dimes. It's actually made up of dimes are x and nickels and y, or y. So again, on 5 through 8, they're all dimes and nickels. Dimes being x and nickels being y. So you might need to make sure you make that change on 5 through 8. But again, so Sarah has 19 coins in her purse made up of nickels and dimes. The total amount the coins are worth is $1.55. Write a system of equations that could be used to determine the number of dimes x and nickels y that Sarah has, then find the number of dimes and nickels. So again, we got 19 coins worth $1.55. So my equations, still 19 is the number of coins, so x plus y equals 19. This time my dimes are x, so 0.1x plus nickels are y, and nickels are 0.05, so 0.05y equals $1.55. So now again I can rewrite that, so x plus y equals 19. 0.1x plus 0.05y equals $1.55. Again, nothing would cancel, so I have to multiply. Again, imaginary 1 in front of the x, so I'm going to put it on bottom. 0.1 in front of the x on bottom, so I'm going to put it up top, and I'm going to make that one negative. So I got negative 0.1x minus 0.1y, and negative 0.1 times 19 is negative 1.9. Then on bottom again, nothing changed because I just multiplied it by 1. So now if I add the two together, again, negative 0.1 and 0.1 cancel. Negative 0.1 plus 0.05 is negative 0.05 y. And negative 1.9 plus 1.55 would be negative 0.35. Then divide both sides by negative 0.05, and you get y equals 7. Then again, y in this case is the number of nickels, so there's 7 nickels. Then you can go back and look at x plus y equals 19. Well, we know y is 7, so x plus 7 equals 19. Subtract 7 from both sides, get x equals 12. Now, the last type of problem that I made up here dealt with dollar bills, or different types of bills instead of coins. So 9 says Sarah has 20 bills in her purse made up of $10 bills and $20 bills. The total amount the bills are worth is $3.20. Write a system of equations that could be used to determine the number of $10 bills and $20 bills, then find the number of each bill. So again, I just wanted to give you another type of problem. It's the same concept. Here though, we've got 20 bills and it's worth $320. So my first equation would be the number of $10 bills, which is x, plus the number of $20 bills, which is y, equals the total bills, which is 20. Then my next equation is going to factor in the cost. So we got $10 bills, so we got 10x plus $20 bills, so 20y equals 320. Again, same concept as the nickels and dimes and quarters and dimes. So now if I rewrite this, I got x plus y equals 20, 10x plus 20y equals 320. Again, nothing would cancel here, so I've got to multiply. Again, imaginary 1 in front of the x on top, so it's going to go on bottom. 10 in front of the x on bottom, it's going to go on top. And we'll make the 10 negative. So I'm going to multiply everything on top by negative 10, so I have negative 10x minus 10y equals negative 200. Then on bottom, everything times 1 again, nothing's going to change, so 10x plus 20y equals 320. Now if I add these together, the x's drop out. Negative 10y plus 20y is positive 10y. Negative 200 plus 320 is 120. So we divide that by 10, and I get y equals 12. And again, y is the number of $20 bills, so there were 12 $20 bills. Then if I plug that back in, again, I would use x plus y equals 20. So y is 12. So I could subtract 12 from both sides, get x equals 8. So there were 8 $10 bills and 12 $20 bills.